All right, we are live. So welcome back to Dapp University. So today we're going to try something a little bit different in our normal live stream time. You know, I do these live streams Monday through Friday in this channel, and today I was like, let's just try to freshen things up and do a coding live stream, okay? Because I've talked about this a few times, and like I've never really pulled the trigger, but we were talking about the stream the other day. People were like, hey, yeah, let's just do it. So we're going to try it today, all right? So you're going to be the first pilot class of my live Solidity coding workshop. So I'm going to give you we're going to code out a smart contract together today in this workshop. You don't have to be an experienced developer. You can learn the basics of programming language as you go. But if you are an experienced developer, then you're going to get something out of this because we're probably going to cover some aspects of the Solidity programming language that you might be less familiar with. So let's go ahead and jump in and get started. So we got people in the chat here. We got Tom, Technically, Automatic Beats, Eric, Norris, Tebo, hope I'm saying this right. I love that somebody put that as their name. Let's see here. Jaya, Bruno, Newbie, Greg, Benjamin, Dale. Welcome, welcome, welcome. All right, so let's go ahead and give this a shot. So, you know, like I said, this is our first day that we're trying to do this. So bear with me if we kind of fumble through some of the implementation here. But I wanted to give this a shot because, like I said, we've talked about this before. And yeah, we're just going to roll with it and see what happens. So what we're going to do is code out Solidity smart contract together over here in our browser. So we won't have to install anything on our computer to get started. You can just head on over to remix.ethereum.org. You don't need to install, you know, any like dependencies on your computer. We can code all the smart contracts in our browser without much effort. We can deploy them, you know, to a blockchain inside of our browser here, and we can test them out by hand, you know, connect our MetaMask wallet, do whatever we want to. Okay, so head on over to remix.ethereum.org. We're going to go to the file browser here, which is going to give us access to, you know, our Solidity smart contract files. You can go ahead and create a new file inside of here and call it hotel room. So we'll skip this. All right. Actually, hold on. We got to put it in the folder here. Sorry, the remix interface gets a little bit finicky sometimes. So we'll call it hotel room, capital H-O-T-E-L. Capital R-O-O-M. So that's the convention for writing Solidity smart contracts. File names is basically you use the capital letter and for each word in the name, and then you use the .sol file extension. So for every single Solidity smart contract file, of course, at the top, you want to declare the Solidity programming language. So we're going to use the latest version of Solidity programming language, which is version 0.8.0. So basically what you do here, I'm going to bump the font so you can see this, is you do this line at the top, which is pragma Solidity. That declares the programming language version. The caret, you know, saying use at least version 0.8.0. So this is the latest version that we use for, you know, production Ethereum smart contracts. Okay. So the next thing we want to do is a new thing that most compilers for Solidity require, which is to add the license identifier. So it's not really Solidity code. It's just this thing at the top that's commented out, okay, where basically you just tell it what the license for the code is, so that the compiler wants to see this type of stuff, because if you go compile it, it's going to say, hey, we don't know what the license identifier is, so you got to put this thing right there. Okay, so basically you just do spdx-license identifier MIT. All right. So what we're going to do is create a hotel room smart contract. It's going to teach you about several different fundamentals of the Solidity programming language, like how to pay with cryptocurrency, how to trigger actions inside the smart contract, like if you do something with whenever you send money around, because basically like the blockchain, the big use case for smart contracts for them to act like vending machines. So they're like these autonomous programs that live on the blockchain, and like whenever you send money to it, it should perform a predictable action, right? It's a contract that something's going to happen. The contract code should not change. Whenever you create transactions, then those can, you know, trigger, you know, instructions in the blockchain to do something. In this case, we're basically going to have it to where you can book a hotel room. So think about like an Airbnb, for example. You know, you could have a smart contract that, you know, corresponded to an Airbnb, and you could send some crypto to that particular smart contract, and whenever, you know, it receives the funds, then essentially it can handle the booking for you. So that's kind of the use case that we're going to cover here when we're handling this particular smart contract. So I'm going to literally just go through this step by step, and I'll put the code down the link in the description below whenever we finish. I'm not going to do it yet. So basically we're going to create the contract like this. We'll say contract, and we'll call it hotel room. All right. And then inside the curly braces where we'll put the code. So basically, Solidity is a contract-oriented language, as I've heard it called. Also a object-oriented language. Basically means that smart contracts themselves are the basic building blocks of every single complex decentralized application or blockchain-based program. So if you ever come from another programming background, like object-oriented programming, objects are the things that, are the basic units. And then you have classes where you can make classes talk to one another. It's the same thing with smart contracts. So, this is sort of like a class in a different programming language, and then you can make all the different classes talk to one another. Similarly, you can make all different contracts talk to one another, and you use everything inside these curly braces is where the code gets encapsulated. So let's talk about what we want the function to fundamentally do. Well, we want it to handle a booking. So we're going to book function here. So we'll say function book. All right, so this is how you create a function inside Solidity. Of course, use the function keyword, then you give it whatever name you want to. All right, so this is going to be book, like the verb book, like we're going to book a hotel room, not like we're going to, read a book or something like that. Okay, somebody says, can we see a hard hat tutorial? Yeah, we've been doing tons of hard hat tutorials inside the blockchain mastery program, but maybe we could do some more hard hat tutorials on YouTube. Somebody says smash the like button. Yeah, definitely smash that like button. So we're going to create this book function. What's it going to do? Well, we're going to call it, and then it's actually going to handle the booking. Okay. So, but what we want to do is send cryptocurrency in whenever we call this function. All right. So again, a function just like it's just a bunch of code that you can call and reuse on a smart contract. You can program multiple steps inside of here, but you can also you could call that with your MetaMask wallet, but you also can send in cryptocurrency with each function call. I'm going to show you how to do that right now. So the first thing that we want to do is store somebody that we want to receive the funds from. Okay, so we're going to create an owner of this smart contract. So we'll basically say address payable owner. I'm going to make sure my code is still visible in my live stream here. Again, this is a new setup. Not used to coding and looking at my live stream and making sure that my code's on the screen. So bear with me, everybody. So we'll say address payable owner. And then we're going to set it like this. And I'll explain this. Constructor. And then we'll say owner equals message.sender. Okay. So what does this mean? Well, basically, Solidity has a really common pattern where you can own a particular smart contract, where basically whenever you put it on the blockchain, you can take your MetaMask address or your address, your Ethereum address, and then you can basically be the owner of it. So you can store that in this thing called a state variable here. So as a state variable, basically it's a variable that's stored on the blockchain itself. You put state variables inside of smart contracts at the top of the contract here. So that's different from a local variable that you might call inside of a function, but state variables are here inside the smart contract. They have scope inside the entire smart contract, which means you can use state variables inside of function calls. You can use them other places in the contract itself. But basically, so it should be 2Ds. Yeah, we store this value to the blockchain. So we store the owner of the blockchain, make it payable, which means that person can receive funds to the actual address whenever we want to, okay? And then we set the owner right here inside this special function called the constructor function. So what is that? Well, a constructor function is basically a special function in Solidity that gets run once and only once whenever the contract's put on the blockchain, okay? So basically, whenever you compile the smart contract to deploy it, this special function is what gets run. And inside of here, what we do is just say owner equals message.sender. Message is a special global variable inside Solidity, and message.sender is a specific global variable that just says, hey, who sent this transaction? So whenever we deploy this contract and put it on the network, that's going to be a specific address, and we create a transaction where that happens, and then that particular address is going to get saved to this state variable here, and we can access that particular address with message value and then save it to the state variable here. Okay. So let's go ahead and actually finish the book function. So basically, the first thing we have is somebody who is saved, okay, to actually receive the funds whenever we create this hotel room contract. So this is going to be the owner, and this is who receives the money whenever the the hotel room is booked. Okay. So now what we want to do is actually send it to them whenever we call the book function. So how do we do that? Well, we can do it like this. We can basically say message. You can do it like this, owner.transfer message.value. Okay. So what this does is it takes the owner here, and we call the transfer function, which sends Ether or Ethereum cryptocurrency, and then we get the actual value that's sent in with the function with message.value, just like this. Okay, so I'm going to go ahead and try to change my screen here, see if this will give me some more space. Yes, it does. Awesome. I'll make sure my live stream software that I still have things visible on the screen. Somebody says my address has 3 Ds. Yeah, yeah, totally. Awesome. Yeah, we just fixed that. So if you guys see any more mistakes on screen, feel free to let me know. Again, we're just trying this out. Live coding is a lot harder than it looks. Okay, so anyways, function book, we do owner transfer message.value. Now I'm going to show you something, another way that you can do this in Solidity is you can say owner.call, okay, and then instead of these, you can basically use these and then do this. So what's call? Well, call lets us send an arbitrary message to a particular address. Okay, in this case, we can send the message, an empty message, but we can basically say message.value, which is the amount of cryptocurrency sent with the transaction, and we can pass that into call. Okay, and then we can get the return value of that. So basically, we can say bool, which is just stands for Boolean, it's a true or false value. So sent, and then bytes memory, and we say data. And then I'm going to collapse this over here so we can. Sorry, the Remix browser. Try to figure out how to make this. Yeah, there we go. Awesome. Okay, so yeah, here we go. So bytes. So sent is going to be whether the success of the transaction, bytes or the message sending, and then this is going to be the data that gets returned. So why we want to do that? Well, it gives us a benefit over the transfer function. There's some differences between call and transfer. I don't get too deep into that, but what we can do is basically make sure that that actually receipt was successful. So we can say require true, or ways we can say require sent. Okay, if we want to. All right. So there's different ways to do that. All right. And then basically we can just say that require sent was true. All right, so this is good. So what is require? Require is a special function inside Solidity that essentially checks a statement as true or false. So basically, we can have different expressions inside of here, and we can say like 1 + 1 is equal to 2. And if that evaluates to true, then we'll resume execution inside the function, and if not, it'll be false. Okay. So this looks like a lot like Node.js. Yeah. It does look a lot like Node.js. So basically, Solidity is a pretty beginner-friendly language. It looks a lot like JavaScript and Python. It's highly influenced by that. So yeah, you'll see a lot of similarities to like Node.js or JavaScript. Okay, so let's continue on here. So we've got the book function. Now what we want to do inside of here essentially is perform an actual booking. So, we've received cryptocurrency here. Let's talk about how to actually update the status of the hotel room itself. So we can use something called the enum. All right, so we're going to say, let's do the enum up here. Say enum statuses. All right, and then inside of here, what we're going to do is say vacant and occupied. Okay. So basically, vacant. What is an enum? An enum is just a sorted list of different options. Okay, and then you can take these options and say what the options are, like vacant and occupied, and then you can reference those options elsewhere inside of the smart contract. So that's how you create an enum. But you can save the enum to a state variable like this. Basically, you can say statuses, and then say. Let's see here, public, and then status, or current, let's say current status. Okay, just making sure my code is not getting cut off my screen here. So status is public current status. So what it's going to do is we've created the enum here. Now we want to actually save what the current status is with status is public current status. And we'll see that in operation here in a second. So I'll show you how. Basically, inside the constructor function, we can set the default status from statuses like this. We can just say, let's see here, current status equals statuses vacant. All right, actually that needs to be capital V. Status is vacant. All right. So that's going to set the default status. So basically, here's the statuses enum that just says what the available statuses are, vacant or occupied. And then you can take statuses public, which makes this accessible outside the smart contract, and get the current status, which is the state variable for, hey, is this hotel room currently vacant or is it currently occupied? So whenever we create the smart contract, it should be currently vacant. And so that's why we do statuses vacant, just like this. How fun do I find the Solidity programming language? I like it pretty well. So somebody's just got here what we code is. We're coding a hotel room smart contract, kind of like an Airbnb. So we're trying this out today. This is a new format. Just experiment with things. We talked about potentially doing coding live streams. I wanted to see how this worked today. Just a little experiment, okay? So status is vacant, status is occupied, current status payable owner. So now inside the book function, what I want to do, we have sent cryptocurrency to the owner, which we saved here. And we've also required that was true. Now what we want to do is also change the status of the hotel room itself to denote that it has been booked. So we have, this status is here. This status is public current status. And then we want to say, basically current status equals statuses occupied. Okay. So that books the hotel room. So right here, we have, the statuses, and we make it vacant whenever the contract's created. And then here we have current status equals statuses occupied whenever we get booked. Okay. So the next thing that I want to do is show you how to basically, let's see here. Yeah, the next thing I want to show you about Solidity Events and then also modifiers for the functions. And that will wrap this smart contract up. So inside of here, we said require sent. And what we want to do now is create an event that the smart contract was actually booked. So what is an event? Event is something inside Solidity that lets you essentially notify somebody else that something happened on the blockchain. So in this case, like whenever we call the book function, you could see that transaction history on the blockchain, but what if you want to get a push notification about it, right? Like say the hotel room got booked, you want to get a notification on your phone, or like, you want to see a history of all the past bookings. Well, that's what events are for, because you can get alerted about things in real time, and then you can get a history log of every single time that event was called. So we're going to do that for the booking function like this. We're going to create a new event here. So we'll say event, I'll call it occupy. And then we'll give it address, occupant, and then uint value. So, Solidity is a statically typed programming language. So basically, anytime you create a new variable, you have to give it the data type. So, occupy is the event name. So first of all, event is an event type. And then we say capital O occupy for the event name. And then we give it the address as the first argument for the event, which is just the occupant. And then a uint, which just stands for unsigned integer. That basically means a number without a minus sign in front of it. So it's an integer that can't be negative. And then we give that as value. So this is how you create the event. Basically, we're just going to tell the blockchain every time somebody occupies the hotel room, we'll tell it the Ethereum address of the person who booked the hotel room, and we'll tell it the amount of cryptocurrency that they paid whenever they booked the hotel room. So this just declares the event. Now we need to actually call it inside the book function. So here we use the emit keyword. So whenever you're triggering an event, you use this emit keyword and you say occupy. And then we pass in message.sender. And then we're going to do, let's see here, message value. Okay. So what is that? So as we emit the occupy event, we pass a message sender. All right, so message sender, of course, is the person calling the function, who's calling this book function. And then message value is going to be the amount of cryptocurrency that's sent with this transaction. Now, one thing I meant to mention before is that whenever we're doing this book function, we need to make it payable. All right, so which basically means that that tells Solidity that you can send Ether or send in some cryptocurrency whenever you're calling this function. Okay, and so another thing is we need to make this payable here. Make sure that's correct. So we can say payable message sender. All right, and then let's see here. I think that's it. Yeah, we also want to make this public. So what does that mean? Well, this is the visibility of the function, okay? So visibility basically just means where, can you see this function outside the smart contract or not? So if you want to call this function, from a wallet or a website, it needs to be public because otherwise, the book function is only going to be accessible inside the smart contract itself. And then payable, okay, is, it's called a modifier, which basically means that this function now has a new property that it didn't have before. In this case, you can send cryptocurrency to it. So I'm going to show you how to create another, modifier here that's going to make sure that you can only call the book function while... But basically, it's what's going to do is check to make sure that the hotel room is already vacant before you book it. Okay. So how does that work? Well, we have this enum here that keeps track of the status. The current status is vacant. And we now are updating the occupied status whenever we book the hotel room. But if we call this function again, we don't want it to book it again twice, right? We want it to stop execution. So we could use this require statement right here, or this require function. We could say require, statuses, or we say current status equals statuses occupied or vacant. All right. And we could give it a message even. If it fails, we can say currently occupied. All right. We could do that here, or we could put it into a modifier. I'm going to show you how that works. So basically, you can create a special modifier. Call it modifier. Say only while open. All right. Or we say only while vacant. And then we can take this and then say require current status equals statuses vacant, and then say public payable only while vacant. Okay. So basically that keeps you from having to put this require in line. And then now we're going to do underline here and then return the body of the function. Okay. And then now we're going to create another modifier that essentially enforces a cost for the hotel room. So basically, we want to set a price for booking the hotel room. All right, in this case, we want the price to be, in this case, we want the price to be 2 Ether. Okay, so basically we want somebody to, I know it's a lot for a hotel room, but we'll just use 2 Ether. So what is this underscore semicolon? That just means return the body of the function. Or execute the function. Or return, yeah. So let's do a new modifier here. And we'll say modifier. We'll say costs. So we'll say modifier costs. And then we can say uint value. And then, or instead of value, let's say amount. Okay. And then what we're going to do is say require message value is equal to, or we'll say it's greater than or equals to the amount. And if it doesn't work, we'll say not enough ether provided. Okay. It's a modifier. I misspelled that. Costs. Uint amount, and say require message value is greater than or equal to the amount, not enough ether provided. And then what's cool is we can say costs, and then we can actually pass in the cost here and say to ether. So that's cool because you can basically say the ether amount like this, like in English, and then you can pass that into the modifier as an arbitrary cost. And you could say it costs 1 ether, it costs 5 ether, it costs 10 ether. But for now, we're just going to say it costs 2 ether. And then say message value, which is the amount of cryptocurrency sent with the transaction, is greater than or equal to the amount that you pass in here, which is this. And that's the function modifier. Okay, so I think I'm gonna zoom out here just to make sure we're good. I think that's it. Okay, so let's check on the live stream, make sure we're okay. Yeah, somebody says 2 ether for a hotel room. I know it's pretty expensive. We're just using examples here. Somebody says commenting code may help audience. I'm not sure what that means. It says underscore value or value. Yeah, I may have messed it up. Hold on, let's see here. I think, let's just go to compile it. Let's see, guys, let's go to compile. All right, so let's see here. Line 32. Let's just check this. Let me just check real quick. Hold on. Okay, so I realized what happened here. Basically, I made a boo-boo. All right, so I forgot I have a syntax error. So what's syntax error? Basically, syntax is programming language syntax. So sometimes this happens. Okay, this is just live coding. Basically, it especially happens when you have multiple programming languages and the syntaxes are changing all the time, especially with Solidity. So what you want to do is owner call and then say value here. Okay. So basically, let me explain that. So what you're doing is you're creating a message inside Solidity, and a message has, you know, different attributes, and so it uses curly braces to denote that, and then you say value is the part of the message where you actually send in the amount of ether. So that's what I missed there. So my mistake, everybody. Let me pull that down so you can see it. So let's compile. Okay. So now another thing says modifier body does not contain underscore, so that's what it's yelling me at for that here. I forgot to put this here. So this is real life software development, everybody. Okay, let's do that. Compile. Okay, so unused local variable data. Let's not worry about that right now. We're just gonna check on sent, and then let's go to compile. So we've compiled. So cool thing about Remix is, you know, so first of all, let me explain compilation step if you're new. So basically what compilation do is it takes the human readable code, which you wrote in Solidity here, and turns it into machine readable code. So basically, you know, human readable code is Solidity that, you know, programmers can write and manipulate and read. And then machine readable code is the code that actually gets executed on your computer, or in this case, the Ethereum virtual machine, which is just the client software that runs the Ethereum nodes. So basically, what's going to happen is you compile that down, and the computer is going to run bytecode. Okay, so that's this compilation step here. Yes, and we see errors in compilation. That's a warning, not an error. And then you can see what the ABI code and the bytecode is by, you know, copy it here if you want to. But let's bypass that. So let's run it. We can get a JavaScript blockchain in our browser, which is pretty cool. So we have that's one of the benefits of Remix is you don't have to install anything on your computer. It runs in the cloud, and you can see this JavaScript virtual machine here, okay? And it gives you a bunch of accounts here, all with Ether inside of it. I'm gonna go to a fresh account because I was just messing around with Remix a minute ago. So I'll go to this account, and this will be the deployer. So we'll click deploy. All right, and then now we can see the new hotel room contract here. Okay. So we can see the current status is 0. So that with enums, basically, this corresponds to a number value. So vacant's going to be 0 because it's 0-based index, and occupied is going to be 1. So the status will tell us that it's 0 or vacant in this case, because that's what we want it to be whenever we set that in the constructor function like this. Okay. Now we can call the book function. So let's change accounts. We don't want to be the owner. We want to be somebody else. All right. And then we want to test that the book function actually works, and that when we send cryptocurrency in with the transaction, it's going to go to the owner, which is this account here. All right. So I'm going to call book, but it's not going to work yet because we need to send in some cryptocurrency. So, because our function is payable, we can send in cryptocurrency inside of Remix with this field here. So this is the value field. So that's how we set message value, okay, is inside this value form field. And we can change the value from way to Ether. And so we can say, to Ether. All right. And then we can call the book function. And it works. It's green. All right. And then let's see here. Let's try it again. And it fails. Awesome. So, well, we tried it with 0. Let's try it again with 2. And it still fails. So now we know that it's... you can see the actual error message here, currently occupied. All right. So we know that it's triggering this only while vacant. It's saying currently occupied. All right. So let's try it. Let's try it again and pay not enough Ether. So let's go. And you can also see that the owner account received the Ether here. So we sent 1 Ether and this received 1 Ether. So let's go back to this account and click deploy. And then let's switch accounts. And let's try to book. Let's see, the current status is 0. And let's try to book with less Ether. So let's say 1 Ether. And then book, and it fails. And you can see not enough Ether provided. So we're actually getting the correct message whenever we do that. We can, do the correct amount. Click book. It works. Try book again. It doesn't work, and we can also get the current status, which is now 1, so it's now occupied, and it is not vacant. All right, so that's it. That's an overview of the hotel room smart contract. So basically, that shows you several different concepts inside of Solidity. Okay, we've got the enums, which are pretty useful. We got events. We've got, how to make addresses payable, how to send cryptocurrency around, how to use constructor functions, how to use modifiers with arguments, how to work with, call versus transfer. There's a lot of concepts all in this one smart contract that you could use inside your own blockchain application. So somebody says, great question here. Somebody says, how to accept tokens instead of ETH. Well, basically, you could do it with ERC20 tokens. It's not going to work quite the same way. What would happen is you'd have to have an approval step first on the ERC20 token, and then you could call the book function, and the book function could call transfer from and bring that token inside the smart contract here. And then basically, you would check the balance to make sure the tokens were received. And if they actually worked, then you could call the rest of the function. So now what I'm going to do is go ahead and take all the code and then paste it inside of a gist so that you all can have it, and I'll put it in the video description. Okay. And then I'll go ahead and put this inside the YouTube chat so that you all can see it. All right, so that is our test of our very first coding live stream on this channel. Again, we've been talking about experimenting with these for a while. I want to just give it a shot today, see how it worked. I thought it went well. Let me know what y'all think down in the comment section below. We'll go ahead and answer a few questions here. So this is just starting. Awesome. Yeah, totally. So the best, if you're just starting out, definitely, learning by building things is the best way to go. You can definitely go check out those free tutorials on my YouTube homepage. I highly recommend also the Blockchain Bootcamp. Okay, we actually have a pretty special announcement coming up at the Blockchain Bootcamp pretty soon, so stay tuned about that. You can go check that out over dappuniversity.com/bootcamp. We have lots of people go through that training and land real world blockchain developer jobs. It's one of the best ways to reskill and break into the industry. How to use receive and fallback. So it depends on your Solidity programming language version. But basically, you could do the same thing where you could use a receive function. Basically, what they're saying is you could just send Ethereum or Ether to a smart contract and then create a function that gets triggered anytime you do that without having to call a special function. You can use those functions for that. So it's truffle or remix. So you really, that should be a truffle, hard hat, or remix question. But it depends. You know what I mean? If we're just doing things with a single smart contract in the browser, I do like using remix. Okay, I wouldn't want to use remix for like full-fledged projects where basically you have to maintain multiple smart contracts and write tests and all that type of stuff. That wouldn't be the right tool for the job. If you're going to write a token or something like that and put it live on the blockchain, you could use Remix. That'd be just fine. I've done that before. I've deployed live cryptocurrencies to the web or to the blockchain just from Remix. But if I'm going to develop an application long term and write tests and maintain it and version control it, I'm definitely going to use a framework like Hard Hat or Truffle. Can you use a struct instead of an enum? Yeah, you could. How do you listen to events on the front end? You could use a library like Web3.js or Ethers.js and subscribe to the events. We got plenty of tutorials, full stack tutorials on my YouTube homepage to show you how to do that. Also extensively into the Blockchain Bootcamp. How to integrate the front end? Definitely go check out those tutorials. It'll show you that. We could try that in another live stream coding tutorial. But today I want to just make things simple and try to do things with Solidity inside the browser so that people can follow along pretty easily, get experience with the programming language, and not be too overwhelmed for our first experiment here. Somebody says, will the bootcamp take us through basics of smart contract to the advanced level? Yes, definitely. Should you approve the Ether before sending it to the function? So you don't have to approve Ether. So Ethereum, cryptocurrency, or Ether works differently from tokens. So it's it's a hard thing to understand when you first get started. So basically, Ether is the native cryptocurrency of the Ethereum blockchain. So basically, if you're going to mine Ether, like if you're going to mine cryptocurrency in the blockchain, that's the one you use. That's, Ethereum's currently proof of work, transition to proof of stake. But if you're going to basically pay transaction fees, you do that with Ether. But tokens are different. So tokens are cryptocurrencies that are powered by smart contracts that go on the blockchain. 'Cause that's one of the beauty of blockchains like Ethereum is that you can create a new cryptocurrency without creating a new blockchain. And you do that with smart contracts with tokens. And so ERC20 tokens are the standard for doing that. And they work differently from Ether. So you have to approve ERC20 tokens before you send them, okay? But you don't have to approve Ether because Ether doesn't work like that. You might have seen wrapped Ether, which is WETH. That's a smart contract where you can send Ether to the contract and wrap it and make it work like an ERC20 token. That's what wrapped Ether WETH is. So you can approve that, but you don't have to approve Ether. That's one of the beauties of it. That's why people like to buy NFTs with it. That's why they like to do different things, is because there's like one extra less step oftentimes than having to do this approval type thing. Somebody says, I'm all new to blockchain development and generally want to create my future in Web 3.0. I don't want to miss the big opportunity. I'm a bit confused where to start. Can you guide me? Yeah, definitely go to my YouTube homepage and find that video pinned there, how to become a blockchain developer in 2022. That's going to show you everything you need to know. How to do something gas optimized. We actually just published a video into the Blockchain Mastery Program on how to do gas optimizations. Can I use NFT assets to code? Yeah, definitely. What's the difference between connect to the Ethereum network directly and connect to a provider like Infura? So basically, like the Ethereum network, so it's the same in both cases. You're both connected to an Ethereum client or an Ethereum node. It's just that with Infura, they're running the node for you. And so you could run your own node on your own computer if you wanted to on your own server. That's what it would look like to use your own node versus use Infura's node. This is risk check. It's the same one as always. Can I convert the hotel contract into the blockchain like Polygon? Yeah, totally, because Polygon's an EVM compatible chain, which means you can use Solidity smart contracts and put them on Polygon. All right, everybody. So my camera is about to overheat, so I need to wrap up the live stream for today. But that's, I thought it was a good, successful test of the live coding workshop today. If you all want to see another one of these, definitely smash that like button down below. That's going to help YouTube know that you actually liked attending this workshop, okay? It's going to show it to more people, and that's going to motivate me to actually want to do more of these, is if people find this video and they like it. Because if nobody watches them, it's really hard to get motivated to get up and do these coding live streams. So hope y'all liked it. Smash that like button, subscribe to the channel. That's the main thing that tells YouTube that you want to see more videos like this. And if you're fascinated with this, if you want to go to the next level, definitely go to my YouTube homepage. Find any of those free courses there. They're like Udemy courses, but they're totally free. And if you went through the massive shortcut and, master blockchain step-by-step start to finish, learn the Solidity programming language in and out, create a real-world project so that you can land a, high-paid job, become a freelancer, whatever, head on over to dappuniversity.com/bootcamp. All right, you don't have to be an expert to get started today. Help people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. And until next time, thanks for watching Dapp University.